Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1 Higher Tier Paper 3 Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1 asks us to circle the inequalities shown in this diagram. So we've got this line that stretches from -7 up to 6. Now the value of x is going to lie somewhere in between these. Now we just need to work out which way around the signs go. Now underneath the -7 we have a filled dot, and the filled dot means that the number -7 is included in the range. So we're going to draw a greater than or equal to symbol between those two. So x is greater than or equal to -7. At the other end of the scale we have an open circle. That indicates that number 6 is not included in the range. So we need to include a symbol like that. So x is strictly less than 6. So our answer is going to be this one. Okay, moving on to question 2. The probability that a biased coin lands on heads is 2/3. So normally when you flip a coin it's going to be 50-50 which way round it lands, either on heads or tails, but this one is biased, which means it lands on heads more than it lands on tails. So the coin is spun twice. Circle the probability of 2 heads. Now just making a quick sketch of the probability tree for this. I throw the coin or spin the coin once and it's either heads or tails, and then a second time I get either heads or tails there or heads or tails there. Now the probability that it lands on heads is 2/3, so this root here is 2/3, making this one 1/3, and the same here, 2/3, 1/3, 2/3, 1/3. Now we're interested in the probability that we get 2 heads. Now the probability of 2 heads is this root, up here and along there. So the probability of heads is the probability of getting heads on the first row, which is 2/3, times the probability of getting heads on the second row, another 2/3. So 2/3 times 2/3, 4/9. That one there. Question 3 says the water is poured into a glass for 4 seconds. The graph shows the depth of the water in the glass. So we can see as time increases from 0 to 4, the depth is increasing steadily. And we need to work out the rate of change of the depth of the water. Now rate of change is the same thing as gradient, so we need to basically work out what the gradient of the straight line is. Now to work out the gradient of a straight line, we need to select 2 points on the graph. on the straight line, and we need to work out what the change in y is and divide that by the change in x. So the change in y here is the difference between 10 and 0, so that's 10 that way, and from 0 to 4 that way is 4. So rate of change is the gradient, and that's equal to 10 divided by 4, which is 2.5. That one. In question 4, we're told that the ratio of x to y is 2 to 3. So that means for every 3 y's, you have 2 x's. Now the question asks us which one of these other statements is saying the same thing. Now they all involve finding the fraction of a number. When you find a fraction of a number, you divide by the number on the bottom and then you multiply by the number on the top. So if I want to find 2/3 of y, I would take the number in of y's, which is 3, I would divide it by 3, which is 1, and I'd times it by 2, which is 2. So that one does seem to work. If I take 3, divide it by 3, times it by 2, I'll get 2. So that statement is correct. Now let's just check the others. So if I had y is 2/3 of x, well, I've got 2 x's. If I divide it by 3, I'm not going to get a very nice number. I'm going to get 2/3. Times that by 2, I'm going to get 4/3. So that doesn't work. X is 2/5 of y. Is that statement true? Well, if I take the number of y's, of which there are 3, and I divide it by 5, I'm going to get 3/5. And if I then times that by 2, I'm going to get 6/5. So that one doesn't work either. I don't have 6/5 of x. I've got 2x. And then y is 3/5 of x. Again, if I take my 2x's and I divide it by 5, I'm going to get 2/5. And if I then times it by 3, I'm going to get 6/5. So that one doesn't work either. So the only solution that is correct, or the only statement that is correct, is that first one. Now the secret of exam success is to be able to correctly decode the command words the examiner is asking of you. So you've got 2 words here: factorise, fully. Now factorise is math speak for putting brackets in, and fully, is, well, it's just signposts that there are more than one factor to find. So if you ever see the word factorise fully, it means that there are more than one factor to find. So here, if I've got 9a squared and 6a, when I factorise, I'm looking for common factors between those 2 terms. So clearly, both of them have an a in them. So I've got an a here and an a here. So they have an a in common. But the number part as well, the 9 and the 6 are both in the 3 times table, so I have a second factor of a 3. So I'm going to take out the common factors and put it at the front. So 3 is common because it goes into 9 and 6, and a is common because it goes into a and a squared. And then I open a pair of brackets, and then inside the brackets are the bits that aren't in common between the 2 terms. What do I need to multiply with 3a to get 9a squared? Well, 3 times 3 is 9, and a times a is a squared, so I have to have a 3a there. And I'm going to have a minus sign in the middle to match that one in the expression. And then I have to work out 3a times what is 6a. Well, 3a times 2 is 6a. Okay, that's the answer. So I factorised it by putting brackets in, and I factorised it fully because I've got both the common factors out. Question 6 asks us to find the next term in a quadratic sequence. Now, quadratic sequences don't go up in even jumps like linear ones. This one, between 4 and 12, is plus 8. Between 12 and 24 is plus 12. And between 24 and 40 is plus 16. So they're not going up in equal jumps, but you can see that there's a pattern in how they are increasing. Plus 8, plus 12, plus 16, and the next one is going to increase by plus 20. So 40 plus 20 is 60. Okay, Ali is going to throw a dice 6 times, and he says, I will get one of each number. Give a reason why he could be wrong. Well, getting one of each number is just one of many different possibilities, actually. And in any case, actual outcomes don't necessarily match theoretical values. So that's what I'm going to write down. Actual results don't always match theoretical probabilities. Okay, part B says Lucy throws a dice 50 times, and here are her results below. So you can see that she's got a table, a frequency table of the number of times each number came up top. We're asked to work out the relative frequency of throwing an odd number. Now, relative frequency is equal to successful trials divided by total trials. Okay. In this case, there were 50 trials in total. It told us that in the question. And we want to work out how many successful trials there were. Well, in this case, success is throw in an odd number, of which there were 7 ones, 12 threes, and 9 fives. So adding those 3 numbers together, 7 plus 12 plus 9, which is 28. So that is 28 out of 50. Now, I could cancel that down, but often in these sorts of questions, you don't actually get any extra credit for cancelling down probabilities. And there is a danger that when you cancel them down, you make a mistake. So the only possible outcome of you cancelling down a question like this is you losing marks. So don't bother. Question 8 shows a polygon ABCDE, and that has been divided into 3 triangles. And we need to use the triangles to work out the sum of the interior angles of a polygon ABCDE, and we must show our working. Well, this polygon has got 5 sides, so it's actually a pentagon. So a 5-sided shape has got 3 triangles that go inside. Your maths teacher might have shown you how to derive the formulas for sum of interior angles of a polygon, and they do involve just dividing the shape up like this into triangles. You know that the angles inside the triangle sum to 180 degrees, so this triangle here adds up to 180 degrees. Now the triangle next to it also adds up to 180 degrees. Its interior angles there. And finally, our last triangle adds up to 180 degrees too. So you can see that those 3 angles there form that interior angle of my pentagon. And then I've got another one there, look, and another one there, another one there, and another one there. So the 3 sets of 180 degrees from my triangle add up to the interior angles of my pentagon. So let's write that down below. What are we going to write? Angles in a triangle sum to 180 degrees. So interior angle of ABCDE equals 3 times 180, which is 540 degrees. Okay. In question 9, we're told that a school has 60% of their students being girls, and of those, 50% of the girls walk to school and 20% of the boys walk to school. What is the percentage of students who walk to school? Now, first thing to note in this question that there's no number of students given, so we're just working purely with percentages. If it makes it easier for you to think about, then you can just assume that there are 100 students. So assume 100 students. Okay. Now I'm going to try and collect all this information in a two-way table because we've got two quantities. We've got boys, girls, walk to school, doesn't walk to school. So I'm going to make a two-way table. A bit like this. So this is going to be my boys, girls, walk to school, doesn't walk to school. Now I know that altogether we've assumed there are 100 students. I'm going to write that down there in the bottom right corner. Now we are told that 60% of the students are girls. So that means the total number of students that are girls are 60, and that means there must be 40 boys, or 40% boys. Now, next we're told that 50% of the girls walk to school. 50% of the girls walk to school. So there are 60 girls altogether. So 50% or half of them walk. So that's going to be 30 there. So if 30 walk and there are 60 altogether, 30 don't walk. Okay, and then for the boys, 20% of the boys walk to school. So we decided there were 40 boys. 10% of 40 is 4, so 20% is 8. So I'm going to have an 8 there. So that makes this one 32. Okay, so adding up along the columns now, I know that 38 out of 100 walk and 62 out of 100 don't walk. So what percentage of students walk to school? It's going to be 38 out of 100, or 38%. Okay, in question 10, we're given the graph of a quadratic curve, and we're also given a partial formula. This one up here, y equals a plus bx minus x squared. So it's a partial formula because we haven't yet been given the values of a and b, these coefficients here. And I imagine during the course of the question we're going to have to work out what those are. Okay, so let's have a quick look at what the questions are asking us to do. A says circle the coordinates of the turning point of the curve. So the turning point of a quadratic curve is going to be its highest or lowest point. Oops. Which is going to be this point here. That's got coordinates 2, 16. So circle the coordinates of the turning point of the curve. Well, 2, 16. Next it asks to circle the value of a. Now coming back to our partial formula or equation for the curve, y equals a plus bx minus x squared. Now a is the constant. In other words, it's the y-intercept of this graph. So we can find a by looking at where the curve meets the y-axis, which is this point here. So that's going to be our value for a. It's not what we normally have as y equals mx plus c when we're looking at straight line graphs. So normally we use the letter c for this. But here they've labelled it a, so that is going to be the coordinates of a there. So that's the coordinates 0, 12. Circle the value of a. It's going to be 12. That's the y-intercept. Okay. Next part of the question, circle the two roots of the equation. Now the roots are where the curve cuts the x-axis. So we can see that the curve meets the x-axis here and here, which is at minus 2, 0 and 6, 0. So let's answer the question now. So the roots are -2 and 6. In question 11, we're told that Adam and 6 other men ran a race. The times in seconds of the 6 other men are shown. The mean time for all 7 men was 9.83 seconds. Did Adam win the race? You must show your working. Okay, so we've got the times for the 6 men that Adam raced against, but we don't actually have Adam's time. So let's use a bit of algebra and call Adam's time x to start with. So we would calculate the mean by adding all 7 values together and then divide by 7. So x, Adam's value, plus all the other gents, 9.79, 9.80, 9.88, 9.94 and 9.98, all divided by 7 because there were 7 runners, and we know that that is equal to 9.83. Okay, I think it's time to reach for a calculator. I'm going to cross multiply that up there, so getting rid of the 7 on the bottom, 7 times 9.83, that is equal to, so 9.83 times 7, 68.81. So I'm going to write 68.81 this side, and then on the other side I've got x plus all those other 6 gents times. I'm going to quickly add those up. 9.75 plus 9.79 plus 9.8 plus 9.88, 9.94 and 9.98, which comes to 59.14. 59.14. Okay, so now we just need to solve for x, taking my 59.14 to the other side and subtracting from my other value, so 68.81 minus answer 9.67. So, did he win the race? Yes, because his time is faster than everybody else's. So I can answer yes. Adam ran the fastest time, so won the race. Question 12 shows a square whose sides have been given algebraically, and we need to work out the length of one side of the square. Now these questions that mix geometry and algebra are becoming more and more common, so expect to have one a bit like this in your exam. So we know it's a square, so those two sides should be equal to each other. So I can equate them in an equation. So I can write down one side of my square, 6x minus 3, must be equal to the other side of the square, 3x plus 1. So actually all I need to do here really is solve for x. I've got a linear equation in x that I need to solve. So let's just remove the brackets on the right hand side first. So that gives me 3x plus 3 over there. Then let's collect all the x terms on one side and the number terms on the other, which will give me 7x minus 3x is equal to 3 plus 3. 7x minus 3x is 4x. 3 plus 3 is 6, giving me x is 6 over 4, which is the same thing as 3 over 2. Okay, done. Or are we? Just make sure at the end of every question you reread it, because I almost missed this. Work out the length of one side of the square. Sometimes when we find x we think, oh yeah, our job is done, but back to our square, our squares are not of side x. I've got one which is 7x minus 3 and one which is 3 lots of x plus 1. We worked out the value of x, so we haven't worked out the side of the square yet. We could use either one of those, so I'm going to use the 3 lots of x plus 1 because it looks slightly easier. So what's 3, what is 3 lots of, so when x equals 3 over 2, then 3 lots of x plus 1 is 3 lots of 3 over 2 plus 1. So 3 over 2 plus 1 is 5 over 2 times 3 is 15 over 2, which is 7.5. Now in question 13 we're told that a circle has equation x squared plus y squared equals 4, and we're asked to find the circle radius. Now the equation of a circle centre origin is always the form x squared plus y squared equals r squared, where r is the radius. So in this case, r squared is going to be equal to 4. And if r squared is 4, that means r must be 2. Okay, question 14 says a, b and c are different prime numbers less than 20, and we're told that a equals the square root of 4b plus c. Work out 2 possible sets of values of a, b and c. Okay, so we've got some puzzle pieces that we need to fit together to in a certain way. Let's first write down what all the primes are between well, less than 20. So the smallest prime number is 2. Then 3, 5, 7, not 9, 11, 13, not 15, 17, and 19. So I've got 1, 2, 3, 4, 5, 6, 7, 8 to choose from. So these are my primes. Now, I need to then pick 3 of these so they fit into that expression. A equals 4b plus c all square rooted. And that's going to have to give me another prime. Now there are lots of possible combinations of 3 things from 8 things. So let's just see if we can think it through a little bit and make the choices a little bit easier for us. Now we're going to have to take the value of b and times it by 4. So I imagine we're going to have to pick our values of b from the kind of lower end of the group. Otherwise, if we multiply them, 17 or 19 by 4, our number's going to get too big, I think. So I'm going to try picking my numbers from b at this end. Now, once we multiply it by 4 and add on c, we're square rooting. So we're aiming to get a square number, aren't we? We can pick a value of b, times it by 4, and add on one of the other numbers, and we're aiming to get a square number. So what are the square numbers? So squares, so we're aiming for 1 or 4 or 9 or 16 or 25 or 36 or 49 and so on. Remember though that a needs to be a prime number too, so I can't just have any square, it has to be of a square of a prime number. So not that one. 2 squared is, 3 squared, 4 squared, not that one. 5 squared is okay, 6 squared, not that one, 7 squared. 9 squared wouldn't be, the next one would be 121 if we're going to get that big. Okay, so let's try a small value of b to start with. Let's try b is 2. So 4 lots of 2 is 8. Now can we pick another prime number to add to 8 in order to get one of our squares that we're looking for? Okay, so let's go through. 8 plus 3 would be 11. No. 8 plus 5 would be 13. That doesn't work. 8 plus 7 is 15. Nope. 8 plus 11 is 19. 8 plus 13 is 21. 8 plus 17 is 25. Now that is one of our options. So 8 plus 17 is 25, and that would be, when I square root it, 25 square root would be 5. So that's one possible solution, isn't it? So that's b is equal to 2, c was equal to 17, and a is 5. So let's write that one in. Set 1, a is 5, b is 2, c is 17. Okay, so we've got one set done. Need to try it again and find another set. So let's try the next possible number. So try b is, let's try another small b. Let's try 3. So again, 4 lots of 3 would be 12. Now can I add another prime number on to get one of my square target ones that I'm looking for? So add in 2 would be 14, that doesn't work. Add in 5 would be 17, that doesn't work. Add in 7 would be 19, nope. Add in 11 would be 23. Add in 13, that'd be 25 again, wouldn't it? So 4 times 3 plus 13 is 12 plus 13 is 15, is 25 again, and square root of that is 5. So again here b is 3, c is 13, making a 5. Now it doesn't matter that I'm repeating a twice, these are still two sets of results. So a is 5, b is 3, c is 13. Question 15 asks us to simplify fully 8x cubed y to the power of 5 all squared. Okay, so we have an index of some things inside a bracket. Now, indices on the outside of a bracket like this are distributive, which means that all the things multiplied inside the brackets get separately raised by the power of 2. So 8 lots of x cubed y to the power of 5 all squared. That is the same thing as 8 squared x cubed squared y to the 5 squared. So 8 squared is 64. X cubed squared is x to the 6. We multiply these indices when we have an index of an index. And y to the power 5 squared is y to the 10. Question 16 has a diagram of a lawn, and we are going to be treating it with weed killer. We're told how much area each can of weed killer covers and the cost of each can, and we want to work out the total cost of the weed killer that we have to use. So there are several steps to this problem. The first step is that we're going to have to work out what the area of the garden is in square meters. Once we know what the area is, we can work out how much weed killer we need, and once we've worked out how much weed killer we need, we can work out the cost of that weed killer. So there are 3 steps to this problem. So let's start off with the area of the garden. Now the shape is a trapezium, so we're going to be using the trapezium function, trapezium area formula, which is area equals a half a plus b times h. That's the formula that we need to use. Okay, so subbing in what we know. So half of a and b are your 2 parallel sides that you need to use. So that's a there, and that's b. So it's going to be 12 plus 20 times h. Now h is the distance between your 2 parallel sides. It's that distance. We have a slight problem here in that we haven't been given that length. We've been given this slant height here, that distance. So we need to work out what the height is first. So let's add in another line down here, making a right angle triangle. Now, we want to know h, the height. We've got the hypotenuse. What is the length of this baseline of the triangle? Well, this one is 12 and this one is 20. So that one at the bottom there is going to be the difference between the two, which is 8. Now, if you've memorized your Pythagorean triples, as you should have done, you already know what the height of this triangle is. Otherwise, you're going to have to use Pythagoras Theorem to work it out. So Pythagoras says c squared equals a squared plus b squared. That's the formula we need to remember. But this time we're finding the shorter side, so it needs to be rearranged. B squared equals c squared minus a squared, which is our longer side, 17 squared minus 8 squared. 17 squared is 289 minus 8 squared, which is 64. So 289 subtract 64, 225, and the square root of that is 15. But as I said, you really need to start remembering what your Pythagorean triples are, because they come up all the time in the exams. There are 3 that come up a lot, which is 3, 4, 5, 5, 12, 13, and this one, 8, 15, 17. So you should really remember these 3 Pythagorean triples. It will help you a lot in exams. So they're called Pythagorean triples. But anyway, we now know the height of this triangle. It's 15, so I'm going to put that in there. So now I can work out the area of my trapezium. So half 12 plus 20 times 15 equals half times 32 times 15 is 240. Okay. So the area of grass that we need to treat, we've just worked out, is a half 12 plus 20 lots of 15, which was 240 square meters. Now, 1 can of weed killer covers 90 square meters. We need to use this piece of information next. We've got 240 square meters to treat, so we are going to need 90, 180, 270. We're going to need 3 cans. You can't buy fractional cans from the shop, and they tend to complain. So you need to buy 3 cans. So number of cans required is 240 divided by 90, which is 240 divided by 90 is 3 cans. Just going to write it down like that. Right, so the cost of each can is £19.25. So cost of cans equals 3 times £19.25. Just quickly type that into the calculator. 3 times 19.25, £57.75. Question 17 asks us to expand and simplify these pair of double brackets. So I'm sure you have a strategy for doing this. I usually do 2 eyebrows, a nose and a mouth. Let's multiply that out. So 2x times 3x is a 6x squared. 2x times minus 8y is minus 16xy. In the middle, 5y times 3x is plus 15xy. And finally, 5y times negative 8y is minus 40y squared. I've got two terms in the middle which I can bring together. So minus 16 plus 15 is minus 1. So my final answer is going to be 6x squared minus xy minus 40y squared. Question 18. The ratio of number of boys to girls at a party is 3 to 4. 6 boys leave the party. The ratio of the number of boys to girls at the party is now 5 to 8. Work out the number of girls at the party. Now, the ratio of boys to girls we're given as 3 to 4 to start with. But notice in the second part we're given the ratio of girls, well, the number of parts of girls is 8, which is twice as much as we've got here. So in order to compare the two more easily, I can scale up this ratio by a factor of 2 and rewrite it as 6 parts to 8 parts. Okay, so we're told that 6 boys leave the party. And then we've got a new ratio of boys to girls of 5 to 8. Now, notice that this 8 here and this 8 here are the same. So the number of shares for girls is the same. And the boys has gone from 6 to 5. So it's reduced by 1. So overall, we've reduced the number of shares of boys by 1 when 6 boys left. So I conclude from that that 1 share is equivalent to 6 students. So if we then take our ratio of boys to girls and times it up by a factor of 6, we will find the number of students of each type overall. So 6 times 5, there should be 30 boys, and 8 times 6 should be 48 girls. So we need to work out the number of girls at the party, which is this number here, 48. Girls at the party, 48. Question 19. In the UK in 2000, 25% of the population were under 24 years old, 50% of the population were 37 years old, and the interquartile range for the age was 32 years. The oldest person was 107 years old. Show this information on a box plot. Now, a box plot has a box in the middle and 2 whiskers and a line in the box like that. That line in the box is Q2, the median. And then we have Q1 and Q3, the upper and lower quartiles, and the whiskers go out to the highest and lowest values. So in order to draw this box plot, we need to know those 5 values there. So let's go through the question and see what it's telling us. 25% of the population are under 24 years old. Now, 25% of the way through a population is going to be the lower quartile. So this is actually giving us Q1. So Q1 is 24. 50% of the population were under 37 years old. So halfway through the populations are medians. Actually, they're giving us Q2 there. That's 37. Now the interquartile range was 32. Now the interquartile range is the distance between the upper and the lower quartile. So we can use our lower quartile 24 and the interquartile range to work out where the upper quartile is. 24 plus 32 gives us 56. So Q3 is at 56. Now the oldest person was 107 years old, so that's given us the maximum value is 107. And what's the minimum value? Because we need to have the lower whisker, don't we? Well, we're going to assume that the the lowest person's age is just fractionally above 0. So we'll put that one in there. It doesn't give us any other information, so that's a natural assumption. Okay, so we've got all the data we need. We can now draw it on. So getting the ruler out, I'm going to draw a line at 24, 37 and 56. 24 is going to be my lower quartile. 37 is my median. And 56 is the upper quartile. You see there are 5 divisions between each 10, so they're worth 2 each. Okay, so just turning my ruler around, joining that up to make a box. And then I can add the whiskers on. So the whiskers go to my min value, so down to 0, and to my maximum value, so up to 107. Okay. So there we go. Job done. Part B says it is predicted that in 2050 the age distribution in the UK will have a lower quartile of 26, a median of 44 and an upper quartile of 66. Make 2 comments about the predicted change in the age distribution in the UK. So I think I want to do 2 comparisons between the 2 different types of data we've got here. A median is a measure of average, so I'm going to compare the medians. And interquartile range is a measure of dispersion, so I'm going to compare that as well. So what is the interquartile range? Interquartile range is going to be Q3, our upper quartile, minus Q1, our lower quartile, which is 40. Okay, so I'm going to be comparing the medians and the interquartile range. So let's look at the medians first. So my new median is 44, and from the first part of the question, my median was 37. So the median has gone up. So in terms of the age of the population, it means that people on average are going to be living longer. So median age has increased from 37 to 44. So people are older on average. And secondly, the interquartile range has increased also. So the interquartile range has increased from 32 to 40, meaning that, well, it means that there's more variation in the ages of people, meaning that there is greater variation in people's ages. Okay. Question 20. An amount of money was invested for 8 years. It earned compound interest at 2.5% per year. After 8 years, the total value of the investment was £11,696.67. Tom is trying to work out the total interest earned, and he's written this down. Interest of for 8 years equals the amount of money times 0.025 times 8. And we need to state what's wrong with this. Now, it'd be probably easier to ask what's right with it, because this is just all sorts of wrong, really. Where do we start? Firstly, he seems to be trying to find simple interest, because it's just taken a flat percentage and times it by 8. which is what you would do if it was simple interest, but actually he's then timesed it, so that's another error with it. So he's not got a lot of it right here. Now there's actually only one mark available, so you only really need to state one of those things to get the mark. So I'm just going to write down he is attempting to calculate simple interest, not compound interest. Okay, but as I said before, that's just one of many things he's got wrong. Right, now next it says work out the total interest earned. Okay, how would you do it then? Well, for compound interest, the final amount is going to be equal to the original amount times the multiplier raised to the number of years, or number of times that the interest rate is going to be applied. Okay, so we are told that we've got the final amount, which is 11,696.67. So let's sub that in. 696.67. Let's find the original amount first. Now we know the multiplier. The multiplier is going to be 1.025 and the number of years is 8. So then rearranging that, our original amount is going to be 11,696.67 divided by 1.025 to the power of 8. Type that into the calculator. I make that 9,600 and change. I'm just going to round that off to 9,600. Okay. Now we're not quite finished because that's the original value and the question asks for the interest earned. So that is the difference between our final amount, this one here, and our original amount. So interest earned equals 11,696.67 minus 9,600, which is 2,096.67. Okay. Now, question 21 starts talking about Mersenne primes. Now, before you go and start complaining to your maths teacher that they've never mentioned Mersenne primes to you, don't worry about it. You're not meant to know what they are. They go on to explain what Mersenne primes are. It's not assumed knowledge for the test. So Mersenne primes are prime numbers that can be written in the form 2 to the power n minus 1, where n is a whole number. So 3 can be written as 2 squared minus 1, so 3 is a Mersenne prime. So we need to prove that 2 to the power 9 minus 1 is not a prime. Well, what is 2 to the power 9 minus 1? 2 to the power 9 is what? 2, 4, 8, 16, 32, 64, 128, 256, 512. So 2 to the 9 minus 1 is 512 minus 1, which is 511. Is that not prime? Now, if 511 is a prime, then it's clearly a Mersenne prime, but is it a prime? Can you think of any numbers that multiply together to give you 511? Well, I don't know actually. Let's see if we can find out. Well, I know it doesn't divide by 2 because it's not even. It doesn't divide by 3 because 5 plus 1 plus 1 is 7, and that isn't a multiple of 3. It's not going to divide by 5 because it doesn't end in 0 or 5. So let's see if it divides by 7. 511 divided by 7. It does. 511 is equal to 7 times 73. So it's not prime. Okay. Next part of the question says there are Mersenne primes where n equals 5 and when n equals 7. Amma says the ratio of the indices is 5 to 7. This means that the ratio of the Mersenne primes is 5 to 7. We need to show that Amma is wrong. Okay, so we need to work out what these numbers are then, don't we? So if n is 5, then so for n equals 5, 2 to the power n minus 1 is 2 to the 5 minus 1. 2 to the 5 is 2, 4, 8, 16, 32. 32 take away 1 is 31. And for n equals 7, 2 to the n minus 1 is 2 to the 7 minus 1, which is going to be 32, 64, 128. 128 minus 1, which is 127. Okay. Well, 31 to 127, that's not going to be equal to 5 to 7. Now these are prime numbers, aren't they? So you can't cancel them down. You're not going to get 31 to 127 to cancel down to 5 to 7. So that isn't going to work. In question 22, we are given a triangle. We've been given a couple of the angles and a side, and we need to find side y. Now, clearly this is a non-right angled trigonometry question because we've got sides and angles and we want to find one of the sides. Now we know two rules that we might apply in these sort of situations, and that is the sine rule and the cosine rule. Now we need to work out which one we can apply here. Now the cosine rule tends to be about 3 sides and an angle. So either you know 3 sides and you want to find an angle, or you've been given an angle and 2 sides and you want to find the third side. So that's the cosine rule. Now that isn't what we've got here. Here we've been given this angle and this side and this angle, and we want to find this side. Now the sine rule is about opposites, so where you've got two pairs of opposites like this, we can apply the sine rule. Now the sine rule says a over sine A equals b over sine B equals c over sine C as well. We don't need that much though. And then we can sub in from our diagram. Here we're going to have y over the sine of 35 is equal to 15 over the sine of 70. Rearranging, y equals 15 sine 35 over sine 70. I've just taken that and moved it up there, if you can see. And now I can type that into my calculator. So 15 sine 35 divided by sine 70. Now just make sure that you check your calculator is in degrees before the test or before your exam, so you don't get any disasters when you type in your trigonometric ratios. I've typed that in and I'm getting 9.16 as my answer. So y equals 9.16 centimeters. Okay. I'm using the emulated version of the Casio ClassWiz in this video. This is a great calculator, and if you're considering moving on to do A-level, I highly recommend that you purchase one of these. There's a link below in the description about it, or there's a card at the top now that you can click to find out more about the Casio ClassWiz. In question 23, we are given an identity. 2x squared minus 20x plus c is identical to a, open brackets, a minus b all squared plus 3b. Now take care here, this is not an equation that you want to solve. You're not wanting to be moving things over that identity from one side to the other. What you want to do is you want to take one side and make it look more like the other, so we can compare all the coefficients and read out the values of a, b and c. So I'm going to take the right hand side of this identity and I'm going to make it look more like the left hand side, and then so we can read off the values. Okay, so I'm going to start off with the right hand side, and that is equal to a lots of x minus b all squared plus 3b. Now multiplying out the brackets, if you're not very good at brackets you might want to write those two brackets out, x minus b, if that makes it easier for you. And then, so that's a lots of x squared minus bx plus b squared plus 3b, which is a lots of x squared minus 2bx plus b squared plus 3b. Okay, removing the brackets, multiplying everything inside the bracket by a, I'm going to get ax squared minus 2abx plus ab squared plus 3b. Now I finish multiplying them out, you'll see that I've got something to do with x squared here, ax squared, and that's got to be equivalent to my 2x squared in my original identity. I've also got something to do with x. I've got minus 2abx, and that's got to be equivalent to that minus 20x there. And I've got some numbers on the end, some constants on the end, which must match up with my constant on the end of that. So I can pair them up. I can say, well, if ax squared is equal to 2x squared, then a is equal to 2. I can say that the 2ab must be 20, and I know that a is 2, so that means 2b must be 10, so b is equal to 5. And I know finally that ab squared plus 3b must be the same thing as c. So c equals ab squared plus 3b, which is 2 lots of 5 squared plus 3 lots of 5, meaning that c is equal to 2550 plus 1565. So c is equal to 65. In 24 we've been given quite a complex diagram with a circle and lots of other angles added in, and we're asked a series of questions. We need to decide whether or not they're true or false. So first up, the first question asks, is it true or false that AC is a diameter? Now, if AC was a diameter, then ABC would be an angle. It'd be an angle in a triangle in a semicircle, wouldn't it? So this one here would be an angle subtended within a semicircle, and it would be a right angle, and it isn't because it's 92 degrees. So AC cannot be a diameter, otherwise that angle would be 90. So I'm going to tick false. False. Angle B is not 90 degrees. Okay, our next statement is angle ADC equals 88. Okay, where's angle ADC? ADC is this angle down here. Is that equal to 88? Well, D and B are opposite angles in a cyclic quadrilateral ABCD, and opposite angles in cyclic quadrilaterals should sum to 180 degrees. So if D is 88, does 88 plus 92 equal 180? Yes, it does. So I agree that D must be 88 degrees. So let's say that's true, and then I can say opposite angles in a cyclic quadrilateral sum to 180 degrees. Right, next statement. Is ABCD a trapezium? Where's ABCD? Okay. Well, if ABCD is a trapezium, then I should have two parallel sides somewhere. Now, to help us decide whether or not that is the case, it would be helpful to find these two angles here. So this one here and this one here. Now, using triangle ADC, which has got angles 88 and 50, I can work out that the angle at A in that triangle is 180 minus 88 minus 50, which is 42. And the other angle, I've got 92, 38, which adds up to 130, so that one there must be 50. Okay. So if I've got a pair of parallel sides, I should have two angles that are alternate in this triangle. Now obviously 42 is not alternate to 38, but these two are equal. So this 50 here and this 50 here are equal, which would imply that this side is parallel to this side. So yes, ABCD is a trapezium. So true. Alternate angles are 50 degrees. Finally, we have to say whether DE is a tangent to the circle. So here's my line DE here, and I'm told that this angle here is 32. So if this is a tangent, then the angle in the alternate segment would be equal to 32. Now the angle in the alternate segment would be this one up here, which is 42. So they don't go together, unless I've added them up wrong. Hold on. Nope, definitely 42. So no, it isn't a tangent. So I'm going to say no. And write that angle in alternate segment would be 32 degrees, not 42. In question 25, we've been given the formula S equals D divided by T, and we've been given the values of D and T correct to two significant figures. Now this question is about working out the upper and lower bounds for S. giving our answer to 3 significant figures. Now, in order to do that, we need to know what the upper and lower bounds of D and T are. Okay, so D is 160 to 2 significant figures. Now, the second significant figure of this number is the 6, which means that D has been rounded to the nearest 10. Okay, now if we imagine a number line, oops, let's do that again. If we imagine a number line and we mark 160 on that number line, then we're rounding to the nearest 10. So the other point I could have rounded to was 150, one below, and the one above that would be 170. Now all the numbers that are round to 160 are the ones that are closer to this number. So the lower bound is going to be 155 and the upper bound is going to be 165. So all the numbers in between 155 and 165 round to 160. Now for our second value, T has also been rounded to 2 significant figures. This time the second significant figure is that 2 there. It's 1/10 or 1 decimal place. Now if I do the similar sort of thing, if I draw a number line and I mark 7.2 and I mark either side of that the possible next 2 marks on my scale, so 7.1 and 7.3, we should be able to see that the numbers that round to 7.2 start at 7.15 and go up to 7.25. Okay, and then all the numbers in between that round to 7.2. Now, when I take S, which is D divided by T, now my maximum value I'm going to get is if I divide my largest possible value of D, which is 165, and I divide it by my smallest possible value of T, which is 7.15, and that is equal to 23.07, which I'm going to round up to 23.1 to 3 significant figures. And my minimum possible value for S is going to be my smallest possible value of D, which is 155, divided by my largest possible value of T, which is 7.25. which gives me 21.37, which I'm going to round up to 21.4. So my upper bound is going to be the largest one of those two, 23.1, and my lower bound is going to be the smallest of those, 21.4. 23.1 and 21.4. Okay, in question 26, I've been given 2 functions of x, f of x equals x squared plus 1, and g of x equals x minus 5. I need to show that f of g of x is that expression there. Now, f of g of x means take g of x and put it inside f of x, which basically means wherever I see x in my f of x expression, like here, I need to replace it with that expression. So I'm going to take my x squared plus 1 and insert x minus 5 in where I see the x. Okay, and then I need to multiply that out, x minus 5 all squared. Now last time I did this, I did it the long way, but this time I'm going to use the identity. If I've got a minus b all squared, then that is a squared minus 2ab plus b squared. This is a very useful identity to remember. It makes multiplying out these things a lot quicker and easier. So that gives me x squared minus, so 2 times a times b in this case would be minus 10x plus 25 plus 1. So then just joining those last two things together gives me that. So, done. Now part B says solve fg of x equals gf of x. Okay, so we've already worked out what fg of x is. What's gf of x? So gf of x is equal to, well, we take our function of f of x and we feed it into our g of x. So this time round, our x is here and we're going to replace it with this expression. So that is going to sit where that is in there. So I'm going to get x squared plus 1, my x, take away 5, which is x squared minus 4, isn't it? Okay, now I need to solve fg of x equals gf of x. Now we just showed that fg of x is x squared minus 10x plus 26. So x squared minus 10x plus 26. And we now know that's the same thing as x squared minus 4. Okay, so our x squareds cancel. And we are left with minus 10x plus 26 equals minus 4. Okay, so I'm going to move the minus 10x to this side, and I'm going to move the minus 4 to this side. So that gives me 26 plus 4 is 30 equals 10x. So x equals 3. In question 27, the examiner has rather kindly reminded us of the volume of a pyramid formula. We are told that the volume of this particular pyramid is 336 cubic meters, and we're being asked to find the angle between VB and the base. So being asked to find that angle there. Right, now in order to find that angle, I think what we need to do is use some trigonometry in this triangle XVB. Now in order to use trigonometry in that triangle to find that angle, we're going to need two sides of the triangle. Now we can use the volume formula to work out the height of the triangle, and we're going to have to use some Pythagoras Theorem along the base somehow to find the other length XB. And once we've got those, we should easily be able to find the angle. Okay, so let's do that then. Let's start off with the volume of the pyramid. So volume equals 1/3 of the base times the height. So in this case, the volume was 336 equals 1/3 times the area of the base, which is a rectangle, 14 times 8, times the height, which we don't know. Let's call it h. So then h is going to be 336 times 3 divided by 14 and 8. So typing that into my calculator, 336 times 3 divided by 14 divided by 8 is 9. So my triangle, sorry, my pyramid has a height of 9. Okay, so we're almost there. Next we need to find the length XB. So kind of this length here we're looking for. Now we can do that by forming a right angle triangle here. So by cutting AB in half, let's just draw that line a little bit more. in line with the diagram. So cutting AB in half, so this line is 7, this would be a right angle, and this side here would be 4, half of BC. So let's just quickly sketch that here. So this was X, this was, let's call that point M, and B, we know that's a right angle, we know that's 4, we know that's 7. So what we want is XB. So using Pythagoras Theorem, XB squared equals 4 squared plus 7 squared, making XB the square root of 16 plus 49, which is root 65. Now that doesn't square root nicely, I'm just going to leave it like that for now. Okay, so now we've got this side here, which is root 65, and we know h is 9, and we've got another right angle triangle here. We can then use triangle XBV to work out the angle. So again, let's just take that triangle out and draw it down here. So this is the tip of the, so it's V, isn't it, at the top? This is the tip of my triangle. So this is X. So this is B down here. So right angle triangle. H is 9. And this side here is root 65. We want to find this angle here. Let's call it theta. So trigonometry in this triangle, if that's the angle I'm looking for, then 9 is the opposite and XB is the adjacent. So I need to use tan. So tan theta equals opposite, which is XV, divided by adjacent, which is XB, which is 9 over root 65. So I need to divide that and then find the inverse tangent of it. So inverse tan, inverse tan 9 divided by square root of 65. I'm making that 48.1 and a bit. So 48.1 to 1 decimal place. 48.1 degrees. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too. And if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.